Hi everyone, welcome to Nckhub. Today in our video we are going to cover Quicksort algorithm as part of data structure and algorithms. So what is Quicksort? So Quicksort is a sorting algorithm which works on the divide and conquer approach. So here in Quicksort, like it's going to take picks an element as like a pivot and partitions the given array into partitions the given array around the taken pivot by placing the pivot in its correct position in a sorted array. So how it works, like we are going to select an element from the given array as a pivot, like first or last or any random element, or so we can also take the median of the array. So we are going to rearrange the array around the pivot. So after partitioning, we can get the elements smaller than pivot will be in the left side and elements greater than pivot will be in the right side. So then we are going to get the index of the pivot and then make recursive call until the two partitioned subarrays like left side and right side of the pivot will be sorted. So with this recursion will get stopped only like there is one element in left in the subarray as that element is already sorted. So this is a simple algorithm. So we are going to take array input as array and starting position as 0 and the length of the array. So when starting index is less than the end position or length of the array, like we are going to partition this given array and then we are going to quick sort. We are going to call this recursive call to get it sorted. Okay, like from array with starting position to pivot. So basically this p is like partition index or pivot index, so till that point of time, and then make a recursive call on the array from pivoting index to the end of the array. So we're going to make a recursive call and then till it reaches this sorted order. So what is there in this partition method is like we are going to consider one element as a pivot and then we are going to compare the elements. So if, if whether the element is less than or less than the pivot. So if that is the case, then we are going to swap the elements with each other and then changing that pivot position to the newer index. So like that we are going to do that. So we'll see on how it works on a working example. So here we taken one simple array with elements of 6 size 22, 8, 29, 13, 19 and 24. So we are considering that leftmost whatever is there in the array, like that as the pivot element. Okay, and left and right are the same, like left and pivot are the same on the first step and right is the last element of the array. So now we are going to check whether my pivot element is less than the rightmost element. So in pivot element we are taking 22 and the right is the 24. Yeah. So since we have taken this pivot element as the left side, so the algorithm is going to starts from right and then move towards left. So now we are checking the elements like pivot element and the right element. So 22 is less than 24. So the algorithm will move towards the left. So that right index which was pointing 24 earlier, now we are going to move the position towards the left side. So that my right position will be 19 and then checking these elements 22 and the 19. So we can see like 22 is greater than 19. So that we are going to swap the elements. Okay, like 22 will be in the fifth and 19 will be the first. So here we can see pivot position change it to fifth index, like it is pointing this 22 number. Now since the pivot is moved to the right side, so now the comparison will move from left to right. So earlier it was in 19, so now the cursor or index position will move to the right side. So now I'm going to check 8 with the pivot element. So this 8 is less than 22, so that we need to no need to change anything. So already these are in sorted order, and then we are moving that to next index 29, and then pivot element is sorry. So next we are going to move to the next index 29 and pivot element is 22. So 29 is greater than 22. So now we need to swap these elements. Okay. So 20 in place of 29 we will be getting 22, and in place of 22 we can see the 29, and also this pivot position will change to third index. So here elements got changed left pivot, and also my pivot is now pointing to the third index, that is 22. So now pivot is on the left side, so again my algorithm will move from right to left. Okay, so earlier it was pointing to 29, so now it is moves to one position advance, like 13. So now we will be comparing 22 is greater than 13. So again we need to uh, swap the positions, so that 22 in place of 22 we can see 13, and in place of 13 we can see 22. So like this we can see 19, 8, 13 and 22, these two positions got swapped. Also my pivot is also changed to that one, 22. Okay, so now pivot is at right side, so algorithm will move to right. So that means my left index position whatever is there, so that is going to move towards right side. Okay, so now all are pointing to the same, like pivot is 22, left is also came to 22, right is also pointing to 22. So all are pointing to same position, so there is no further movement, so we are going to terminate the procedure here. So now we can check uh, before this position whatever is there left side, so all the numbers are less than 22, and right side, so numbers are greater than 22. So now what we need to do, so we need to recursively call this quicksort method, so that these elements will be sorted again. Okay, so 19, 8, 13. So this is left subarray, and 29 and 24 this we call it right subarray. So we can call it recursively. So on the left subarray and right subarray. So after sorting we can see 8, 13, 19, 22 will be the same, 24 and 29. So after sorting, so we can see this type of result. So now we can see the sample implementation. So here I have taken one small example of array, whatever we have seen, like now 22, 8, 29, 13, 29. So I just created one object for my class quicksort demo, and then just printing the elements of the array, and then calling this quicksort method. Here we can see array, and then starting beginning position, start position, and then end position. So that is n minus 1. So when we go inside this method, so first we are checking whether this is start is less than end or not. So if that is the case, I'm just doing the partition. Okay, so in partition, so I'm taking one pivot position, so that is the array of end, and then I'm just calculating the starting. So that is start minus I. So start minus 1. Sorry. And then I am iterating one for loop on the jth variable by using this jth variable and till it reaches the end of the array, so that I am iterating. So if my current element is less than the pivot element, so I am just swapping the elements. Okay. Otherwise, if I'm not doing anything. So if nothing happens, again at the end, I'm just swapping this pivot element. Okay. So the equal array and then returning this I plus 1. So returning whatever I am returning, so that is the partition index. Okay. And then finally I am calling again this quicksort for partitioning this. So whatever after partitioning, so we are going to get this subarrays like which are in sort, which needs to be sorted. So left array is like less than the given pivot number, and right side we are going to get the greater than the pivot number. So like that we are going to again recursively call that to get it those in the sorted order. So now if we run it, so we can see before sorting, so elements are in this or 22, 8, 29, 30, 90, 24, and after sorting 8, 13, 19, 22, 24, 29. Yeah, that is, yeah. So now we'll see like yeah, time complexity for quicksort algorithm. Best case and average case is order of n log n, and in worst case it is like order of n square. And for space complexity for quicksort it is order of n log n. And yeah, thank you so much, guys.